Hello everyone, this is Deepak Kumar, Assistant Professor in Kite Group of Institution. In today's session, we will discuss the concept of heap sort. So these are the content of today's session. First, we will discuss what is heap. Then we will discuss about complete binary tree. Then how can we insert and delete an element from the heap. And then we will discuss the heap sort, and then we will discuss the heapify method to create a max heap. So what is heap? So heap is basically a tree based data structure where the tree is complete binary tree, and the heap also have some heap properties. So this heap properties depends upon the types of heap that we are using, that is minimum heap or maximum heap. So now we will overview the concept of complete binary tree and what is minimum heap and maximum heap and what is their properties. So if we are talking about complete binary tree, so in complete binary tree, each level is completely filled except from the last level. So just see the example of this complete binary tree. Here we have total 4 level 0, level 1, level 2 and level 3, where level 0 to level 3 is completely filled, but last level, that is level 4, is not completely filled. Okay, but in the last level the nodes are as left as possible. That means if we want to insert a node in the last level, then the node must be inserted from left to right. Okay, so let's suppose if the position of L is over here, let's suppose L is not over here. So if L is not the left child of F, so it violates this property that nodes are left as possible. Okay, because L is the right child. So in binary tree, in complete binary tree, each level is completely filled except from the last level, and the nodes are as left as possible in last level. So the next one is types of heap. So as I told you that the heap is of basically two types, the maximum heap and minimum heap. So if we're talking about maximum heap, so maximum heap is nothing but it is basically a complete binary tree in which the value of each internal node is greater than or equal to the value of the children of that node. Okay, so that means each node is greater than to its children. So in this way, the root node of maximum heap is the highest node. Okay, because all the childrens of root node are less than the root node. So what is the max heap property? The property is that the key of a node is greater than or equal to the key of its children. Okay, so that is the properties of max heap. If you take heap, so what is min heap? The same thing is implemented for min heap, but in min heap the node value is less than or equal to its children. Okay, so in this way the root node in min heap have minimum values. Okay, so that is your min heap. So now the concept of heap is clear. So heap is basically a complete binary tree, and it must satisfy the maximum heap property or minimum heap property. It depends upon that which type of heap we are considering. Okay, so actually we want to perform heap sort. So in our heap sort process we generally use max heap properties. Okay, so let's suppose if we have this array that is 16, 14, 10, 8, 7, 9, 3, 2, 4, 1. So this is basically your max heap representation of array. Now just consider an example of max heap where the node have where the root value is 16 and the child of this root is 14 and 10. The child of root node 14 is 8 and 7. The child of node 8 is 2 and 4. So here each node have values greater than to its children. 16 is greater than 14 and 10. 14 is greater than 8 and 7. 8 is greater than 2 and 4. 7 is greater than 1. 10 is greater than 9 and 3. Okay, so this is basically an example of max heap. So in max heap, root node is the very first node. Okay, so here root of tree is represented as a1. Actually here we start with indexing from 1. You can start with indexing from 0, but when you start with index 0, then this formula is changed. Okay, so this is the formulas for indexing 1. Okay, so the root node will be at 1, that is a1. And if we are talking about any node, let's suppose if we are talking about this node root 2. So what is the left child and right child of this node? It can be easily identified via the formula. Left child of ai is equal to a of 2i. That means left child of 2 is equal to a of 2i, that is 4. So what is the left child of 14? The left child of 14 is 8. So if 14 is the element, so what is the left child of this 14? That is at index 4, that is 8. And what is right child? That is 2i plus 1. So 2i, what is I? I is equal to 2. So 4 plus 1, that is 5. So 7 is the right child. Okay. So using this formula, we can calculate the left child and right child of a particular node. Okay. So in this way, we can represent a maximum heap in the form of an array. If we are talking about a parent node for a particular node, let's suppose if we want to find out the parent node of this node 14. So actually the parent node of this node 14 is 16. And what is the index? The index is 1. So the parent node is calculated by a of floor of I by 2. Okay. So let's suppose I is 2. So 2 by 2 is what? 2 by 2 is 1. And floor of 1 is again 1. So what is the parent of a2? The parent of a2 is the parent is equal to a1, that is 16. Okay. So in this way we can easily find out left child, right child as well as the parent of a particular node. So now we are just discuss the concept of heap sort. Actually in heap sort we have two steps. In the first step we just create or build a max heap. Actually here we are just choosing an example of max heap. You can also choose min heap. So first of all we just create or build a max heap and then we delete all the elements of max heap one by one. Okay, so when we delete all the elements of max heap one by one, then actually we just perform sorting. We just find out the elements in ascending order. Now we will discuss each step one by one. And now we will focus on the first one, that is create or build a maximum heap. So let's suppose if we have an array having 5 elements, that is 4, 1, 3, 2 and 16. So how can we create a max heap? So as we know that if we are using max heap, the first thing is that it is a complete binary tree. And the next thing is that each node have values greater than or equal to its children. Okay. So we will start with the very first node. The first node will be the root node. Okay. So this is the first node, 4 I will take in. Then we have a next element 1. So we know that in complete binary tree, the node are as left as possible. Okay, so in the next level, the node must be available in left. So 1 is the left children of 4. Okay, next 3, so 4, 1. Right now we don't have any left space, so we just put 3 over here. Next is 2, so now this level 1 is completely filled. Next is 2, so this 2 will move towards next level. So 4, 1, 3 and 2 will be in the next level, but it must be as left as possible. So 2 is the left of 1. But right now it is not a maximum heap. Why? Because this child value must be less than this particular node, because each node have values greater than or equal to its child. So we have to perform swapping. Okay, so this 2 will be moved over here and 1 will be moved over here. Okay, so now it will look like 4, then 2, 3 and 1. Okay, now this satisfies the properties of max heap. So again we insert the next element, that is 16. So when we insert 16, so 16 will be inserted over here. When we insert 16 over here, then again it not satisfy the properties of max heap, because the node have values greater than to its children, but here the value is 2. So we just swap these values. Now 16 will be here and 2 will be here. Okay, so finally we will get 4, 16, 3, then 1 and then 2. But again it not satisfy the properties of max heap. So again we swap this for 16 and 4. Okay, because 4 is less than 16. So now the position of 16 is over here and 4 will move over here. Now this tree will satisfy the property of max heap. So it is a complete binary tree. Yes, it is a complete binary tree, and each node have values greater than to its children. Okay, so in this way we just create a max heap. So we will start with the first node and then insert a next node one by one, and also satisfy the properties of max heap as well as complete binary tree. Okay, so when we create a max heap, then it will take order of n log n time. Okay, so the complexity is order of n log n. Why order of n log n? Because if we want to insert an element, then it depends upon the number of levels, because how many times we have to perform comparison, it depends upon the number of levels. So in complete binary tree, the number of levels are log n. So log n is the number of level in complete binary tree. So if we want to insert an element, so what is the complexity? The complexity is log n. If we want to insert n elements, so what is the complexity? The complexity is n log n. Okay, so this is the complexity for inserting an element or creating a maximum heap. So can we use any other method so that this complexity is reduced to order of n? Yes, we have a method that is known as heapify method. So in heapify method, the complexity is order of n. Now how can we use this heapify method? How it will be implemented? Actually, when we creating a maximum heap, then what we do earlier, first of all we take this root element, then we insert next element and satisfy the max heap properties. Again then we insert next element and satisfy the heap property, and so on. But in heapify method, we will start with from the last. Okay, so let's suppose if we are talking about this, that is 16. So 16 is basically the leaf node. So if it is a leaf node, then it is already a maximum heap. Okay, so there are no changes will be performed. Then we will move towards here at index 4, that is 2. So 2 is again a leaf node, so it is a maximum heap. Then we will move towards the next index, that is 3. So 3 is again a leaf node, so no operation is performed. Next we will move towards this index, that is 1. So now we have to implement the heapify method. That means we just check the properties of maximum heap over here. Okay, so in heapify method there is no need to check these leaf nodes, because these leaf nodes are already a max heap. We have to focus on the internal nodes, okay, having a children. So if we are talking about complete binary tree, so in complete binary tree the leaf node will start from floor of n by 2 plus 1 to n. Okay, so these are the leaf nodes in a complete binary tree. Let's see over here. So in this particular case we have total 5 elements. So n is equal to 5. Floor of 5 by 2 is 2 and 2 plus 1 is 3. So from 3 to n, what is n? N is 5. So from 3 to 5 is our leaf node. So from 3 to 5 these are our leaf node. Okay, but in heapify method we worked on non-leaf node. Okay, so we have to work on these two nodes. So actually when we are using heapify method, then we generally start with node having indexing n by 2 and then we will move towards 1. Okay, so actually here we have 5 nodes. So 5 by 2, what is the value of 5 by 2? The value of 5 by 2 is 2, and we will start with from this indexing, that is 2, and then we will decrease the indexing and we will reach towards the root node. So in this way we just decrease the complexity for maximum heap creation. Okay, so now we will start with the indexing of the non-leaf node that have a largest index. So in this particular heap we have 2 non-leaf node, that is at index 1, at index 2. But which one is the largest index? This one is the largest index. So we will start with this particular indexing. Okay, so for I is equal to 2, we check that this tree satisfy the max heap property. So this subtree is not satisfy the max heap property, because this node having values less than to its children. So what we do, we just perform swapping. So here both children are greater than from this particular node. So which elements we have to swap, 2 or 16? So now we will compare in between 2 and 16. Which one is greater? 16 is greater. So we will swap 1 and 16. Okay, so 16 will be here and 1 will be here. So finally we will get 4, 16, 2, then 1 and 3. But again it is not satisfying the max heap property. Now we will check the indexing I is equal to 1. So when we check index I is equal to 1, that means this subtree. So again this subtree is not satisfy the max heap property. So what we do, we will swap this 16 and 4. So 16 will be here and 4 will be here. Now this tree will satisfy the heap properties, maximum heap property. Okay, so it will represent it as an array as 16, then left is 4, then right is 3, then 16, 4, 3, then 2 and 1, 2 and 1. Okay, so when we create a max heap using heapify method, then the complexity is order of n. So the first step of heap sort is complete, that is create a max heap. Next what we do, we just delete each node of max heap one by one. Okay, so when we find out the maximum heap, then the array representation is like this. Now we will delete node one by one. So when we want to delete a node from max heap, then always root node is deleted. Okay, so when we delete this root node, So how it will be replaced by other node? So the other node that we choose is basically the rightmost element of the last level. Okay, so rightmost element of the last level is 1 over here. So now this 1 will be placed over here. Okay, and this 16 will be deleted. So now 16 will be over here and 1 will be placed over here. Now we check that it satisfies the heap property or not. If it not satisfy the heap property, then we perform swapping of the elements. Okay, so actually here it not satisfy the heap property. So what we do, we just swap the values. Actually 4 and 3 both have values greater than 1. So which elements will be swapped by 1? That is greater. So 4 is greater than 3. So 4 will be swapped by 1. So 4 is here and 1 is over here. Okay. Now again it will not satisfy the heap property because 1 is less than 2. So now we will swap these two elements. So finally we will get 4, 2, 3, 1. That is 4, then 2, 3 and the next one is 1. And 16 will be deleted. Actually one element is deleted. So one space is vacant over here. Okay. In this space we just put the deleted elements. So actually we deleted 16. So 16 will be put over this vacant space. Okay, this node is not the part of max heap right now. Okay, so right now max heap basically contain these 4 elements. Okay, okay, then again we check, that is 4, 2, 3, 1. So 4, 2, 3, 1. So what we do, we delete the root element. Okay, and which element is replace this root element? That is the rightmost element of the last level. So in the last label we have only one element, so that element will be placed over here. So now it is 1, 2 and 3 and 4 will be deleted, but still it not satisfy the max heap property. So first of all we just convert it into max heap by swapping the element, and finally we will get 3, 2, 1. So again we have one vacant space. Now this deleted element will be placed over here. Okay. Now these two elements are not the part of the max heap for deleting an element. Now we have these 3 elements. Okay, then we have 3, 2 and 1, and we delete the root. Which element is replaced this? That is 1. So 1 and 2 is over here. It is not satisfy the max heap property. We perform swapping of the elements. Now 2 will be here and 1 will be here, and 3 will be placed to the vacant space. Okay, again we have 2 elements, that is 2 and 1. Now what we do, we just delete the root element. When the root element is deleted, then this 1 will be replaced the root node. So now 1 is the position over here and 2 will be deleted. This deleted node will be placed to the vacant position. Okay, now we have 1 elements, and finally we will get an array which have sorted elements. Okay, so this is the way through which we perform heap sort via the 2 steps. In the first step we just create a max heap using heapify method, and in the next step we just delete all the element of the max heap one by one, and finally we will get an assorted array element. Okay, now we will discuss how can we write an algo for heap sort algo. Okay, and here we just use a heapify method. So as we know that in heapify method we just start with from node n by 2 and we will move towards the root node, that means at indexing 1. So in this particular example we have total 5 nodes. So what is the n by 2? N by 2 is 5 by 2. So 5 by 2 is what? That is 2. So we will start with the indexing 2. Okay, that index will be considered as the largest element. So here we just use this max heapify function. Here we just pass 3 arguments. The first one is the array, the next one is the number of element, and the next one is this indexing I, from where we just start. Okay, so initially the I value is 2. So this I value is placed over here, and initially the largest is also pointing to this particular index. So int largest is equal to I. L is equal to 2 cross I. So what is L? L is equal to this one, that is 2 cross 2 is 4. And what is R? R is equal to 5, because 2 cross 2 plus 1, that is 5. Then we check while L is less than equal to N. So L is what? L is 4. 4 is less than 5. Yes, the condition is true. And A of L, A of 4 is greater than A of largest. Yes, A of 4 is greater than A of largest. So if here both condition is true, then what is the value of largest? The value of largest is L. So now L will be the largest element. Okay. So now what is L? L is largest. Again we check while R is less than equal to N, R is 5, 5 is less than equal to 5. Yes, the condition is true. And AR is greater than A largest. AR is what? 16. Now what is A largest? Now this is not your largest. Now largest value is updated and largest is pointing to this one. So 16 is greater than 2. Yes, the condition is true. Now what is largest? Largest is equal to R. So now this is your largest element. Okay. Now this one is the largest. So again we check if largest is not equal to I. Initially the largest and I both pointing to the same element. But right now largest basically pointing to this element and I is pointing to this element. That means largest is not equal to I. The condition is true. Okay. Then we have to perform swapping. Okay. That is swap A of largest comma A of I. So A of largest is what? That is 16 and A of I is 1. So these two elements will be swapped. Okay. And again we just use this heapify method. And in this heapify method we just pass largest element. Okay. So here the largest is what? That is this one. Okay. If this is the largest, so and we perform heapify method. So as we know that this is basically a non-leaf, that is your leaf node. So there is no need to perform heapify method, and then we will pass the index value I as 1. Okay. So in this way this heapify method is actually work. Now we just write an algo for heap sort. So in heap sort we just pass these two arguments, that is array and the number of elements. We will start for I is equal to n by 2. I think the reason is very clear to you why we start I is equal to n by 2, because in heapify method we have to work with non-leaf nodes. Okay, and non-leaf nodes start from n by 2 to root node. Okay, that is index 1. So we will start with the non-leaf node having largest index. Okay, so actually here we have two non-leaf node, that at index 1, at index 2, but which have largest index, that is 2. So we will start from here while I is greater than equal to 1. Okay, then we call max heapify method. So this for loop is basically used for building a max heap, and then when the max heap is builded, then we have to delete elements of max heap one by one. Okay, so this for loop is for deleting the element of max heap. Okay, so here we will start for I is equal to n. Now why we start for I is equal to n? Because we know that the deleted element will be placed at the last index. Okay, when we delete the first element, then this deleted element will be placed at the last index. When we delete the next element, then that element will be placed to the second last index, and so on. So here we will start with n. So for I is equal to n, I is greater than equal to 1, what we do, swap of a1 comma ai. Always the first index value will be swapped. Why the first index value will be swapped? Because in the first index we have root node, or we know that when we want to perform delete operation, so always the root node will be deleted from max heap. Okay, So that's why here we always use this swap a1 comma ai. And then again we recursively call max heapify method, that is a comma n comma 1. Why we pass 1 over here? Because this root node will be swapped from the last node. Okay, so that's why here we just pass 1 as an argument. So this is basically the heapify algo through which we can create a max heap or build a max heap, and the complexity of heapify method is order of n. So this is all about your heap sort. Now we will discuss the next concept in our next lecture. Thank you so much.